Alright, PreCalc, we are with parabolas, starting our review of all of our conic sections from Algebra 2. So we know a conic section, or simply a conic, is the intersection of a plane and a double-napped cone. Notice in the formation of the four basic conics, the intersecting plane does not pass through the vertex of the cone. So here's our four conic sections that we usually think of, and the slice does not go through the vertex of the cone. If it does go through the vertex of the cone, then we get a point in a line, or two intersecting lines. When the plane does pass through the vertex, the resulting figure is a degenerate conic. There are several ways to approach the study of our conics. You could begin by defining conics in terms of intersections of planes and cones, as the Greeks did, or you could define them algebraically in terms of the general second-degree equations, like that. However, we're going to study a third approach, which we did look at in Algebra 2, in which each of the conics is defined as a locus, or collection of points, satisfying geometric properties. A circle is defined as the collection of all points that are equidistant from the center, which leads to our standard form of the equation, x minus h squared plus y minus k squared equals r squared, where h and k is your center and r is your radius. We have learned the graph of a quadratic function is a parabola that opens up or down. The following definition of a parabola is more general in the sense it is independent of the orientation of the parabola. A parabola is the set of all points, x, y, in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus. So we got that focus dot, the directrix line, and all of the points that are equidistant from those two things will make up our parabola. The midpoint between the focus and the directrix is our vertex, and the line passing through the focus and the vertex is your axis of the parabola. Note the parabola is symmetric with respect to its axis. Using the definition of a parabola, you can derive the following standard form of an equation for a parabola whose directrix is parallel to the x-axis or to the y-axis. Alright, let's take a look. So these should be pretty familiar to you from Algebra 2. Okay, we got x minus h squared equals 4p times y minus k, with a vertex of h and k, and p is going to be our distance from our focus to the vertex or from the vertex to the directrix, because they should be equidistant. And then we have y minus k squared equals 4p times x minus h. Okay, so we're used to seeing y equals x squared, so this is kind of flip-flopped. Y equals x squared, that's going to be our vertical one. X equals y squared is going to be our horizontal one. Okay, we got some pictures here to help you. Alright, we got x minus h squared equals 4py. If p is positive, we're going up. If p is negative, it's going down. Okay, and again, the y squared one, we're used to seeing y equals x squared, so if it has y squared, you know it's going to be a sideways one. Alright, let's get into it here. Example 1. Find the standard equation of a parabola with the vertex at the origin and focus at 2, 0. So if our vertex is at 0, 0, the origin, and our focus, I'm going to use a star, so it's just a little bit different, is at 2, 0, that means our P distance is 2. Okay, so origin is 0, 0, so our H, K is at 0, 0. Our focus being at 2, 0 then tells me our P is 2. is a sideways one. How can I tell? Here's our vertex. Here's our focus. It's going to have to go from the vertex and bend around the focus, so it's going to go sideways. So we need a y minus k squared equals 4p x minus h. That's going to be our starting point. Okay, 0, 0 was our vertex. Alright, well, y minus 0 is just y squared. And p we said was 2. Let's put that in there, times 2. X minus 0 is just x, so y squared equals 8x. Also, some extra information that we could do, if our p distance is 2, we know our directrix should also be 2 away on this side, and it's going to be a vertical line at x equals negative 2. And we should be able to have our sideways parabola over there. All right. Example 2. From this equation, find the focus of the parabola. Okay, so we are given it here in y equals form. We're going to have to rearrange it into a different format that we can find a little more easily. Okay, so we have y equals a negative, so it's going to be going up and down. Actually, it's going to go down. It's vertical. It's going to go down because it's a negative multiplier. So we're going to have something of the form x minus h squared equals 4p y minus k. Alright, so we're going to try to get it into this form. Alright, so step 1, we're going to multiply both sides by negative 6 to get this out of here and over here. So now we got negative 6y equals x squared plus 4x minus 2. Okay, think about our completing the square. Go way back, completing the square. Half of 4 is 2. 2 squared is 4. So I need this to be a 4. Okay, I need this to be a 4. That's not 4. So you got two options now. Well, I know I need it to be a 4, so I could add 6. Or you could move this over first and then be like, oh, I need this to be a 4, and then add 4 to both sides. You might have worked on adding 2 first here, so let's just add 2. Because you know that's not the right one to have to complete the square. And then maybe now we thought about it. Half of 4 is 2. And 2 squared is 4. So we want to add 4 there. So we have to add 4 there. And the whole point of doing that was so we could complete the square. X squared plus 4x plus 4 is x plus 2 squared. Okay. We got negative 6 and 6. We can pull out a negative 6 multiplier in the front. Y plus 1. Oh, look at that. Looks pretty close to that. Just flip-flopped, right? Because we have the y on the left. We could turn this around. 4p y minus k equals x minus h squared. So my vertex is at negative 2, negative 1. Okay. This is the p-value, so, or 4p. 4p equals negative 6. Divide by 4, p equals negative 6 fourths, negative 3 halves, negative 1.5. So the focus is going to be 1.5 down, and the directrix is going to be 1.5 up. Oh, we took out a negative, so this is going to be a minus. Shoot, that's going to flip everything. So there, 1.5 down is here, 1.5 up is there. Sorry, lost a negative sign. Okay, plus 1. Okay, so our focus that we wanted to find is going to be 1.5 down from that. Negative 1/2. Our directrix would then be 1.5 above that. Y equals 2.5. Not that it was asking for it. Okay. What? No, don't make that mess in here. Stop it. 3. Find the standard form with vertex and a focus. Then write the quadratic equation. Alright, so our vertex is 1, 3. So we can just sketch this out. Focus is 1, 5. So I know it's going to be a vertical parabola. Just a sketch just for my reference there. X minus h squared equals 4p y minus k. So here's my vertex. So we're going to have x minus 1 squared, 4p y minus 3. Our p distance there is 2. All right, and so our standard form is right here. Not too bad. Quadratic form, we got to multiply all that out. So x minus 1 squared should be x squared minus 2x plus 1. 8y minus 24. We're going to add the 24 over. Alright, and we are not going to divide everything by 8. We're just going to multiply by 1/8 to the whole thing. That's as good as we're going to get there. We're not going to distribute that through. Alright, folks, there you go. So we're playing around with the standard form of a quadratic from Algebra 2. Make sure we got those formulas down. Alright, thanks for watching and good luck. Do some practice problems out of the book. Check your answers with the key on Schoology.